Hello everyone. Let us discuss about characteristic equation of a matrix. Let A be any square matrix, then the characteristic equation of the matrix A is that of A minus lambda equals to 0, where lambda is called the characteristic values, or another way we can call as eigenvalues. Properties of characteristic equation of a matrix. Sum of eigenvalues of A is equals to trace of A. Very important. Product of eigenvalues of A is equals to its determinant. Eigenvalues of an orthogonal matrix are of unit modulus, and eigenvalues of a unitary matrix are also of unit modulus. A and A transpose have the same eigenvalues. The eigenvalues of a skew Hermitian matrix are always purely imaginary or 0. Next, eigenvalues of a triangular matrix are its diagonal elements. If lambda is the eigenvalue of A, then 1 by lambda is the eigenvalue of A inverse when det A is not equals to 0. If lambda is the eigenvalue of A, then det A by lambda is the eigenvalue of adjoint A when again det A not equals to 0. Lambda 1, lambda 2, so on, lambda n are the eigenvalues of A, then eigenvalues of A square are lambda 1 square, lambda 2 square, so on, lambda n square. Next, very important, Cayley-Hamilton theorem, which states that every square matrix satisfies its characteristic equation. Let us remember the characteristic equations of a 2 by 2 matrix A, B, C, D, which is lambda square minus sum of the elements of the principal diagonal into lambda plus det A, which is AD minus BC equals to 0. Similar way, characteristic equation of a matrix of order 3 by 3 is lambda cube minus sum of the diagonal elements into lambda square plus sum of the cofactors of the diagonal elements into lambda minus det A equals to 0. Let us see a question. Consider a matrix A equals to a matrix of order 3 by 3 and the homogeneous system Ax equals to lambda x, where x non-zero. We need to find the sum of all values of lambda. Options are 12, 15, 18 and 4. So let us see the solution. Given homogeneous system is Ax is equals to lambda x, which in other way we can write as Ax minus lambda x equals to 0, which we can write in other way A minus lambda I of x is equals to 0. So finding the characteristic equation of it, which is A minus lambda I equals to 0, we get the values of lambda. We get the values of lambda of whose we need to find the sum. So instead of finding the characteristic values, based on the property sum of eigenvalues of a matrix is equals to its trace. So based on that we can directly find out the trace of the matrix, which is same as the sum of the values of lambda, which is 18. Same comprehension. Next question in that, the product of values of lambda we need to find out. Options are 140, 144, 152, 162. Here also, instead of finding out the values of lambda, we can directly make use of the property product of the eigenvalues of the matrix is equals to its determinant. So product of the values of lambda is equals to, we get 162, which is the determinant of the matrix. Next example, consider the matrix A, which is of order 3 by 3. Then a cube minus 6a square plus 10a minus 5i equals to. Look at the options. In general, we need to find out a square, a cube, and we need to substitute here, and we should verify with the options. Instead of that, look at the solution. Finding the characteristic equation of the matrix given, which is lambda cube minus 6 lambda square plus 11 lambda minus 6 equals to 0. And based on Cayley-Hamilton theorem, every square matrix satisfies its characteristic equation. Hence, at the place of lambda, we can substitute A. So we got a cubic equation in A, from which we can get the value a cube minus 6a square plus 10a minus 5i is I minus A. Next, differentiation of determinant. We can differentiate a determinant differentiation of determinant. We can differentiate a determinant by one row or one column at a time, keeping the others unchanged. You can observe here delta x be a determinant of order 2 by 2, which contains the functions f1 of x, f2 of x, g1 of x, g2 of x. If we need to differentiate this determinant, we can do it the first row derived keeping the second unchanged, plus keeping the first unchanged second row we can derive, or we can do it by column. Differentiation of determinant can be done by one row or a column at a time, keeping the others unchanged. For example, observe the determinant delta x, which is named as of order 2 by 2, which contains the functions of x. So delta dash of x is given by f1 dash of x, g1 dash of x as the first row, second row f2 of x, g2 of x. That means deriving the first row keeping the second row unchanged, plus deriving the second row keeping the first row unchanged. Or we can derive the determinant column wise also. Integration of determinant. Let us consider delta x a determinant of order 2 by 2, where a row contains the functions of x and the other row contains the constants. Then integral of that determinant is given by integral a to b f of x dx, integral a to b g of x dx, keeping the second row unchanged. One important note, this formula is applicable only if there is a variable in one row or column. Otherwise, expand the determinant and then integrate. Let us see an example. Delta x is a determinant of order 3 by 3 is given, which is given a polynomial in x of degree 4. Then what is the value of a1? Look at the options 0, 61, 161, 191. So instead of expanding the determinant and equating to the given polynomial, we can directly differentiate the determinant and we can get the value of a1. Look at the solution once. To get the value a1, differentiate the given determinant and put x equals to 0. So differentiating the determinant column wise. So differentiating the first column, keeping the second two unchanged, and next differentiating the second column, keeping the first last unchanged, which is equals to a1 plus 2a2x plus 1 4a4 x cube. So by putting x is equals to 0, we get the value of a1, which we get 161 as the answer. Next example. Let f of x be a determinant of order 3 by 3, then the value of integral f of x under the limits pi by 6 to pi by 3. Here are the options: minus 16, 16 by 3, 8, 0. See the solution. As we discussed earlier, the given determinant contains the functions of x in all the rows. Hence, expanding the given determinant, we get the value 4 cot x cosecant square x, and integrating it under the limits pi by 6 to pi by 3, which we get the answer 16 by 3. One more example. If f of x is equals to a determinant of order 3 by 3, then the value of integral x square sin x by 1 plus x power 6 f of x dx under the limits minus 3 to 3 is, you can observe the determinant given. The third row contains the elements which are the derivatives of the elements of second row. So derivative of x minus 2 is 1, derivative of 2x plus 2 is 2, and derivative of 3x minus 1 is 3. And one more thing you can observe, the second row elements are the derivatives of the elements of first row. So based on that given function, we can derive f dash of x can be written as deriving the determinant by row wise, deriving the first row keeping the second two unchanged, deriving the second row keeping first and third unchanged, deriving the third row keeping first and second unchanged. We get in every case two rows identical, hence the value of determinant is 0. So we can say f dash x is 0 means f of x is a constant function. Why? Because derivative of a constant function is 0. Hence, to get that constant, let us substitute x as 0 in the given function. So we get the value of the determinant as 2. Hence, we can conclude the function f of x is 2. And next, the other function which is given in the integral, let us name it as g of x, which is x square sin x by 1 plus x power 6, which is an odd function. Yeah, by seeing this g of minus x equals to minus g of x, we can conclude that it is an odd function. Hence, integral in between the limits minus 3 to 3 f of x into g of x, which is equals to 0. Hence, the value of the given integral is 0. Next, use of sigma and pi in determinant. If dr is the determinant of order 3 by 3, where the first row contains the elements in terms of r and the other two rows contains constants, then sigma of delta r, use of sigma and pi in determinant. Let us consider a determinant named as dr of order 3 by 3, which includes the first row elements in terms of r and the next two rows contains the constants. Then sigma of dr can be taken as sigma r equals to 1 to n f of r, sigma r equal 1 to n g of r, sigma r equal 1 to n h of r, keeping the other two rows unchanged. And pi of the determinant can be taken as the first row substituting r as 1, f of 1, g of 1, h of 1 into second row keeping r value as 2, f of 2, g of 2, h of 2, so on. Last, keeping r value as n, the first row we get f of n, g of n, h of n, keeping the other two rows unchanged. Thank you very much.